Hiya guys, welcome back. Terry from Smooth's Workshop here. We're into part 3 of my gadget review and build of the 2.4 inch TFT digital DSO Shell Oscilloscope. So in the first part we showed you what was in the kit, and in the rather long second part I showed you me putting all the additional components on, and in this third part we are going to do the setup. Now in the setup, we've done up to here. Yay! It asks you to check some voltages. So for this, we will need a multimeter, which I have got sitting off to the right here, and my DC power supply to power it up. Now, what it doesn't say on the checking the voltages, I'm assuming it's with the unit off. So I'm just going to do the same as I did last time, and I'm going to put this little jack in the bottom because it's what I've got handy, and we're going to have the positive in the middle, centre pin positive. And I'm just going to check the voltage on my unit before I connect it up. We're at 8.1. Right, now going with the notes on here. So it's telling you to put the analog board on, which we've done. Apply 9 volts power to the main board. Okay, let's do that, see if anything blows up. Right, done that. No smoke, no flames. This is in the off position, so it hasn't told me to switch it on or anything like that. And then it's set the couple switch to ground position. So that's that wee switch at the top, that's on ground position. And check voltages at the points shown in the photo. Okay, so let's have a go at that. Right, I'm just going to get my meter out. So first thing I'm going to check is, let's get my meter on here. I'll turn my backlight on so you can see what we're on about. Hopefully that'll show up. Right, zero them out. Right, okay. Take that back off. Right, so let's just see. Now, it's referring to the measurements it's given you is for an input of 9.3 volts. So what have I actually got going into the meter? Come on, auto range. 9 point, oh god, it's a bit slow. Come on. Let's try putting it straight into my meter here. What have we got? 9.4. Let's just fine tune it down. 9.3. Can you see that? Unfortunately, the light doesn't stay on very long, so we're at 9.3 volts. It's actually showing 9.2 on my supply, but we'll go with what it says on the multimeter. So it's telling me there's a little DG ground down there. Let's see if I can just scroll in on that for a wee second. Down in the bottom left, DG ground. So that's where I'm going to put the negative of the probe. And then we have all these points to check. So let's just get these the right way around. So with my negative probe on the DG ground, first one it's asking you is V plus should be around about 8.35 volts. So where's the V plus? Ooh, there's V minus. Where's V plus? Is it up here? There's V plus. So if I go into V plus, I should be looking at around about 8.35 volts. It's sitting at about 9.2. But it is saying that this measurement's applicable for a certain version of PCB, so right, 9 volts, okay. AV plus, which is, there's AV minus, there's AV plus, should be sitting at 5 volts plus or minus 2%. I've got nothing. Does that mean, have I got the right one? AV plus? Oh, try to get connection, I think, is the issue here. I did have something a minute ago. Or does it have to be switched on? Right, well, stuff lighting up now. Right, okay. It doesn't tell you it has to be switched on, but it's switched on. So my V plus, this one, 8.4, 8.35, that's about right, okay. AV plus, they're wanting that to be around about 8.35. Oh, no. AV plus, 5 volts plus or minus 2%, so that's 5.14, so that's within 2%, that's near enough. Then the next one is V minus, they want that to be, so there's V minus. Oh, V minus down here. And they want that to be around about minus 7.86 volts. I'm reading minus 0.8.17, so that's not bad. AV minus is your minus 5 volts line. Yep, bang on. V1 should be at 0, which it is. V2 should be 0, which it is. V3 should be 0. Where's V3? Where's V3? Up there. That's... there's a voltage on that one. I'm getting minus 3 volts. It says it should be 0. Okay. And V4 should be 1.65. So where's V4? 1.64. Right, I'd say they work. I would say that was within the tolerance. It doesn't tell you that you had to turn the thing on, but apparently to get the right voltages you have to turn it on. So that's the first section done. So I can now put my multimeter off to one side. So now it's wanting us to adjust the trimmers. Now the probes supplied with it are just ×1, what they call a ×1 probe. It just reads exactly what you put in, but they're crocodile clips. Now I have purchased, I'm just going to come back to the bench a little bit. Didn't know at the time exactly what one to get, because I'm kind of new to oscilloscopes, but you get them in different megahertz. Now they're supplying these now. You can get a kit instead of with the crocodile clips on them and the BNC. They actually give you 100 megahertz ×1 and ×10 probe on it, although I believe this is only compatible with ×1. It's to do with resistance. With ×10 you can flick it on ×10 and it keeps it on the screen. So this was cheaper, so I've only got a 60 megahertz one, but I'm hoping it'll work. And then we go into the setup of said probe. So let's just take this out of here. And the other thing is, this is the other thing that's confusing me, is there's also adjustment on the probe. So I don't know if this is going to muck it all up. There's obviously no adjustment on these. It's a straightforward 1-to-1 what goes in. So I don't know whether to set it up on this and then plug this in and adjust it on the adjustment, which is there, or whether I should do the whole setup on this. I don't know. So I'm going to have to play it by ear. Oh, there's my wee piece that goes on. Did I take this one off and then put that one on? I think that's what you do, don't you? And then that gives you your wee hooky clip on the end. So I'm going to try hooking in. See, I don't know with the adjustment on this. What should I do, folks? Because it actually asked me to set it up on 2 different voltages, so I'm thinking it should actually be with the probe I'm going to be using. Right, so hopefully this doesn't come off. Right, now let's just put this probe on for a start. So we've got a BNC connector, which should go in and clip in like that. Okay. Just make sure all my other powers and everything have got a good grip, because I'm using this loose connection here. Ah, they're falling off, I will of course make up something better than this for when I actually go to use the thing, because running it off my oops, I've bent it over. Running it off my power supply is not going to be feasible when I actually got to use it, so I will rig up a 9-volt battery pack, but I have bent that down. Right, let's get this. Right. Positive in, negative on, power on. Stuff's happening, it's booting. Right, now it tells you a little trick when you're setting it up. Tips: perform vertical position alignment before calibrating C3 and C5. So you need to go into the back of the instructions. Where's the vertical position one? Vertical position alignment. Set the couple switch to ground, which it is. Hold down voltage division button for about 3 seconds. Right, welcome back to the fun of setting up this DSO shell. Now, it doesn't tell you in the instructions that I got that you have to switch the switch on the top from ground to DC. So that's the first thing. So let's power this thing up. So let it boot up. Excuse me, still getting over the man flu. We have a waveform. Yay! Right, now, to centre this waveform on the screen, if we press and hold the voltage division for about 3 seconds, it should stick it in the middle, which it has. Okay. Now, the next thing was, we press and hold the adjust button for 3 seconds, and it comes up with the, you can either have the 0.1 for adjusting one capacitor, or the 3.3. So we're going to have it on the 1.1. Again, I want to centre this waveform, so if I press and hold the voltage division, there we go, it's centering the waveform for us, so we now have a square wave. Now, I've got the trigger set to auto. You can have it on auto. Hold on. Right, auto. Okay. Or normal trigger, where you preset the trigger, which is a little pink indicator on the right. Or you can have it on single shot, so that as soon as something activates, it will do a one-shot trigger. So we're going to have it on auto. Okay, so it'll auto trigger. if we press trigger again, there's a little icon in the right hand side. Now it's quite hard to make it out, but the first one has an arrow going up the way, which means it's catching, it's going to trigger on the rise. And if we adjust it the other way, it's going to trigger on the fall. So if you've got a sine wave, you know, this is a square wave, but basically if I have it, that's going to trigger on the fall. But I want it triggering on the rise. It doesn't tell you that. Okay, so we want that set at auto. 0.1 volts set up for the first capacitor. We want the voltage per division set to 50 millivolts. So you can adjust it up and down, that's your... Okay, so we'll have it set at 50 millivolts. Click that back off again. Excuse me. Now, this adjustment on the right, if I scroll this up and down, is actually my trigger level. Let's centre this again. We can actually manually set that as well. To bring it down so that the waveform is sitting on the middle line. Like so. But we're going to have it triggering on auto. I've changed it. I don't want 0.1 volt DC, we want 50. Right. So as you can see, we've got a wee waveform here. So with a plain screwdriver, the capacitor that we adjust for the 0.1 volt one is capacitor 3, which is the one to the right. And all it does is we're wanting to try and square off this wave. So let's see if I can keep this on camera and show you this at the same time. So I'm going to knock it out of alignment if I can. Now you will notice there's a little bit of noise on this, these wee jaggy wee lines, and that's noise. So as you can see, that's more up at the right. So if I turn it the other way, and if I go too far, it goes down at the right. So what you're trying to do is get it looking as square as you can. Basically. So that's for that. Now we want to do it on the 0.3. So let's take it to the, 3.3 volts. So again, press and hold the V division. That'll centralise it. It's quite hard on this to get it. Let's change the time rate. 0.1, 0.2 seconds per division. Right, let's have it on 0.1. Again, let's... The trigger's on auto. I actually do want it to trigger though. Oh, it's not adjusting this time. Right, can we adjust this? Just trying to... single shot, that's why. I'm back on auto. Right, self-center this again. It's still going a bit fast. Let's slow this down. Right, 0.2. Okay. Again, it's just to square this off if it looks like it needs adjusted and you do it with capacitor 5. That looks okay to me. So basically that's that set up. Now if I press and hold the OK button, it should come up with, oops, it's running away there, so it's telling me that we've got a 1 kilohertz signal. It's cycling at 0.999 milliseconds. Pulse width is about 0.5 milliseconds and the duty cycle of just under 50%. Voltage max 66 millivolts. Voltage min minus 75 millivolts. Voltage average, yeah, it's wavering a bit. Voltage peak to peak is 140 millivolts, and VRMS, it's an average. Voltage random mean square, it's like an average of between peak to peak. So it'll be roughly about half of what the voltage peak is. Again, you can turn that back off by holding this down, if I remember rightly. Oh, how do we get these back off again? Or is it trigger and OK? Well, I can't remember how to get them off now. Give me a second, I'll shoot it over here. So that should be it calibrated for that. Measurements for 3 seconds, on or off the display. So 1, 2, 3, that's it back off again. Right, so that's that set. Right, so I'm going to turn this off, and just for a matter of fun, see if I can get it working with my probe, and will I need to adjust anything. And if I need to adjust anything, it should just be, if it'll come out, I should just have to adjust it on the probe itself. Let's see what happens when I put my wee 60 megahertz probe that I got on it. Right, oh, hold on, get my voltages and that sorted out again. I'll need to make up a proper jack for it, but this is a bit of a toy. It can save waveforms and stuff like that, but I think it's a bit of a toy. So let's get this on. Let's fire it up and see what it comes up with. Right, so let's centralize it. I've got 50 millivolts there. Let's 0.1, 0.5, center it, and that. Oh, there we go. Right, so it's looking reasonably square. Let's try it on the 3. And that's looking reasonably square. So that should be it, in theory. You see the noise, it's floating in the background there. There is a bit of ripple, a bit of interference in the background, but there's our... So I can get my probe working with it. But I've set it up initially with the crocodile clips. So, time to get it all together. So I'll unclip that and I'll take this out. And I'll take my power off. Switch my power supply off. So it was a bit of a faff. Instructions aren't very clear on how to set it up, because initially I just got a line going across and couldn't get anything. But obviously you have to set it into the DC coupling mode and not the ground one, because if you put it on ground, all you get is a line going across. So that's how you set it up. Hopefully that's a bit clearer than the instructions. And now all it remains is for me to put all this together. Now, where's the back? This is the back. Let's just adjust my camera a little bit. So we have to take off the... Let's get it the right way around. Because one of them has a pole in it, which is for the bottom, I think. Yeah, that's for the bottom. Right. So we need to remove the analog board carefully, because it screws into the back of here with 4 little screws. Okay, now just to make sure I get it central and everything, I'm going to put on these and slide it in. Right, so it's going to be the 4 of the smaller screws. So let's see if I can find them from my pile of screws. There's one. Oops. There's 1, 2. That's a biggie. Yeah, so sorry for this video being so long. I've got a rough idea. It's been a while since I've used a proper oscilloscope. There's not so much faff in setting up a proper oscilloscope. Because you're basically just clip it on and adjust your probe itself. You're not having to pull it apart and adjust capacitors inside. Excuse me for coughing. Right. So now we have to screw the analog board to the back plate. Try to do this on camera. What's under here? Right. So hopefully it centralizes itself. So I'll come back on camera when I've got that done, because it's a bit hard to see what I'm doing on the board whilst on the camera. Back in a second. Okay, I've got my seat in the camera a better working height. So that's just mounted on with the 4 screws on the back and the ports on the top. And there you see where we're going for the AC, DC ground. You've got to make sure it's in DC for checking DC, and AC for obviously alternating current. But there is a limit on this, and it tells you maximum 50 volts peak to peak. So your 100 volts DC is a max. I wouldn't have put 100 volts DC through this. But obviously that's going to be the same for AC, so you're not going to be able to test mains voltage on this. It is a toy. So the next thing I need to do, I need to make sure that this connector mates properly with the pins on here. So let's see if I can get that sitting correctly. I've also got to get that tab through. So this is going to be a bit of a, it's a bit of a fiddle actually, with the tang in the top. You've got to, let's pull the camera out a bit so you can see what I'm on about. Right, you've got to put that through the top. Okay, and obviously this is screwed down, and you've got to try and get that 8-pin jumper in. It is a tight fiddle. A bit of wiggling, a bit of persistence. Hopefully the pins don't bend, and it will. I've also got to make sure that this LCD screen is still all in situ, which it appears to be. Yep. And this is a faff. But I've got it. Right, so onto those 4 pins like that. That obviously sits across there. Then we need to make sure that we can get this on. So let's get this on next. Okay, like so. So that's all that on. And then this, allegedly, now does it appear to have, it does have a way up, because there's a longer slot at the top, which marries up with that one. So hopefully this should go over the top of here like so. Kind of all clipped together, and then there'll be 4 longer screws hold this baby together. So let's just put some protection under it whilst I'm putting it together. Now it does appear that they give you too many screws, which is always better than not enough. So there's 1, 2, 3, 4, And I appear to have one spare long one and one spare short one. So now it's time to screw this together. I'll just get them started. Now I did notice there was a bit of a bow in it when I was initially testing it to see how it went together. And I wasn't expecting this to be like a high-end oscilloscope or anything. It's going to help me play about with some of my electronics projects and possibly help explain to people what's happening. But it's not going to be as good as a proper oscilloscope. But then you might say to yourself, how often are you going to use an oscilloscope? It depends what you're doing, eh? So let's see, let's get this all screwed in. It does seem to be coming together. But for the money, it's a toy. A no bad wee toy, is the way I would look at it. It's not a serious piece of equipment. Right, so they're all kind of tight. I would definitely say it's not going to be in the slightest moisture proof. Now can I get my button on? That's the next thing. Will the button go into place? Oh God, I knew that would be a tight one. Not easily. I have got quite strong fingers, but this is a bit ridiculous. Do I dare try and pull it back off again? Risk damaging the... I'd like it to go on a bit more than that. It's bloody tight. Slightly at an angle. Yeah, it's not very well formed. I'm not going to mess about with it much more than that. As long as it works, it'll do me. So all my buttons are working. My on-off switch, that's working. And my ground, I'll keep it set to DC. I shall put my... Now, this is a times 10 times 1 probe. You flick between times 1 and times 10 with that. I don't think it supports it. So I'm not going to be messing about with it. I might mess about with it later. If I'm measuring something that I know is at 5 volts. If I go on times 10, that would make it 0.5 volts. It would show in the meter. That's the idea behind it, so you can put higher voltages through, but I'm not going to be putting much high voltages through this. So, okay. Where's my power? There's my power. Oh, yeah, it kind of lines up. It's not the best fit. It's not the best fit, but it goes in. Right, so let's see if I can get this baby powered up first. And then I'll have a bit of fun with it. So, I don't see me using these. That's my adjuster for my other probe. The good thing about this as well is it's got a connector on it to go on the end of the probe if you want to go a direct connection into a signal generator. Couple of a spare tip, little orange colour markers. I haven't put any colour markers on it as yet. As I say, it's only a 60 megahertz probe I got. I should have maybe got 100 megahertz one, but I mean, I couldn't afford 100, so I just got 60, because I wasn't sure if it was going to work or not with this. But as I say, the ones I've seen listed now do have the 100 on it. Where was the paperwork for that? Yeah, 10 ma. So it was just a cheap one. A wee cheapie. Keep that all together. But yeah, the one I should have went for was 100 megahertz, but it was just a bit out of my price range at the time, and I just wanted to get this thing made. So I might invest in 100 megahertz later on. So it depends if I feel this is worth it or not. Right, so that was an additional thing. So what you get with is just those. So let's try this again and see if it powers up after me clipping it all together. Just give the screen a wee, I'll give it a proper wipe later, but just a little bit of a wee clean. Because I've got a little circuit I can test it with. So, let's get the negative on. And I'll make up a wee battery pack for it, off the 9 volts. So, that's my power supply on. So what I've got here is I've just got a little circuit. It's a little oscillating circuit. I'll show you it working. Where's my battery pack? Something I'm playing about for to show people later in the electricity series. So, yeah, let's get the plus in the plus. Excuse me. The plus in the plus. And the minus in the minus. Let's see if my little oscillating circuit works first of all. Yeah, so that's it working with the 2 LEDs, 2 transistors, 2 capacitors. Most of you guys, if you're into electronics, you'll know an oscillating circuit. So I now need to find my probe. So I want, let's see, what can I check? I could check to see if my meter will show the capacitor charging up. So I'm going to clip around the capacitor leg on the positive. Okay. And let's see if I can find something to stick in for a negative leg. There we go. I keep hold of all these wee ends. Right, so let's stick that in the negative. That'll give me something to put my negative probe on. So there's the plus, there's the minus. So I'll connect this up first. So my probe is on the positive of that capacitor there. And what I'm wanting to see, let's let this boot up, is if this can pick up the capacitor charging and discharging. Right, so I don't want that, the TS amplitude, take that off. Right, okay. So let's centralise it first of all. There we go. We can see it's going up and down. Let's put it at, because I'm running it at about 5 volts, 2 volts per division will be good. And let's adjust the time base. Centralise it. We'll change that a bit more. 20. Right, so what we're getting there is the capacitor charging up and then it dumping, charging up and dumping. Let's change the, that's 5. Yeah, because it's roughly working at about 1 hertz or 2 hertz, thereabouts. There we go. So that's it, picked up that waveform. I should be able to, is it, centre it with that one. Yeah. 1 volt, 2 volt. It's a bit slow in responding, actually. Two, 1 will put the peaks higher. I know I'm running it on 6, but I was wanting to see what would happen if I put it on 5. Five volts per division. Yeah, so it's only coming up like 1 division. And if I put it down to 2, oh. So we can, right, let's centre this, take that off and centre it. I should be able to adjust that once it starts, or bring it, there we go, I can adjust it there so that my baseline is running along the middle there. So 2 volts per division, so we're about 2 divisions, so that's showing about 4 volts, and what that's showing there is a slight ramp up as the capacitor charges, and then it boom, discharging up, boom. Obviously if I adjust the time frame, .2 of a second, so that kind of hit at the same time as what it's doing. It just kind of shows you what's happening, and it's handy for different things. So if I was to take it off of that and put it on the base of this transistor, it should show me the transistor base energizing and switching on and off. So it lets me check that. And we'll go on to the positive of the, I don't think there's any point like going on to positive of the LED, but it lets you play about with circuits. Let's go into the, is that the positive leg of the LED there? So that's the signal that the LED's getting. There's a lot of noise on that, obviously, because it's on a breadboard. There you go. It's kind of, the power ramps up to it, it uses it up and it goes away. So yeah, it's good for wee things like this, but it's a toy. It's a total toy. And it's sitting there and there's a load of noise in the background. So yeah, a success. It works, and it works with my probe. So I hope you've enjoyed this. The next part to go with that, to show you a bit more about what these things do, it's more as a learning experience, is I've got a signal generator from KKMoon. It's a kit that you build up yourself. Obviously I'll be able to use it to show you what it does on this little oscilloscope, all the different waveforms and stuff like that, but the idea being, what a signal generator is used for is you inject a signal into a board, and then you use oscilloscope to trace the signal across the board and find out where the signal stops and what component's not working and stuff like that. So that'll be the next one. This does work. Yeah, it's a bit of a toy. It takes a little bit of getting used to and setting up. But I'm pleased to announce it is working, and yeah, apart from the knob on the front, that's a bit, how you doing? Yeah, I'm quite happy with it, and I'll be playing with it in lots of little experiments so that I can check things out. But it is a bit of a toy. So I hope you enjoyed that. Feel free to support me on Patreon. Tiers start from $1 a month. It just helps keep the channel going. So there'll be a link down there. Hopefully that's helped my viewer with the setup part of this, because my instruction sheet was quite confusing. I eventually figured it out. I had to go off camera, figure it out, got it set up. Hopefully this helps them with the setup. So as always, enjoy what you're doing. Thanks for joining me. Remember to click subscribe and the little bell icon if you want to be notified of any new videos. And until the next thing in my electricity series, I wish you all a very good day. Bye now.